This is the first linear patterns video, and so we get a bunch of these types of problems in both 8th grade and Algebra 1. So there's a lot of different questions, but the point of these videos is to show you that no matter what it looks like, no matter what they ask, it's really the same thing that you do every time. Okay? So in this particular one, we have sort of a geometric pattern with these lines going right here. Okay? So it's saying A says to describe the growth pattern shown above. B says, what is the relationship between the step number n and the number of toothpicks t? And then C is asking how many toothpicks could be needed for the 40th step. But one thing that you'll find when we go over these in class is I really tell the kids, don't worry so much about answering the questions right away. The first thing you're going to want to do is you're going to make a table to organize the information. So that's exactly what I'm going to do. So this question here, B says the step number is n. So I'm going to make a table and I'm going to put n right here. And then it's saying that these are toothpicks, and so I'm going to use a t right here. And if you want, you can write step number here and toothpicks here. That's fine. But just make a little table like this. And then step 1. So I have step 1, step 2, and step 3. So I'm going to put a 1, a 2, and a 3. Okay. So this is going to be step 1, this is going to be step 2, and this is going to be step 3. And then what I'm going to do is I'm going to count the toothpicks. Now, believe it or not, this is actually a huge problem for kids is they miscount. So be very careful when you're counting. But as long as you count correctly, you'll see this is pretty easy to do. So I have 1, 2, 3, 4, 5 toothpicks for step 1. For step 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And for step 3, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I can see what's happening each time here is that it's going up by 4. All right, so in addition to people miscounting when they do things like this, the other mistake I'll see a lot of times is people will count step 1 and they'll count step 2 and they'll look at their table and they'll say, oh, it's going up by 4, and then they'll just add 4 and get 13. Now in this particular case, you might say, well, what's wrong with that? Well, if you miscount on step 2 and then you continue the step on the adding number that you're using on the next step, you're going to mess it up pretty bad. So I always tell kids, do not shortcut like that. Count every single step when you do it, okay? Just in case there's mistakes. Then if you notice that these numbers aren't the same number every time, it usually means you miscounted somewhere, as I said, is one of the main mistakes that kids make with this. So the next thing I'm going to do is I'm going to find what's called the 0 step. So that might sound like a really weird thing, but it's an actual thing when it's linear rules. We call that the 0 step. And all I'm going to do is I'm just going to go ahead and count backwards here. So I have 13 to 9, 9 to 5, and then 5 minus 4 would be 1. And then what that does is that follows my, move the paper. That follows my pattern. So it's plus 4 all the way. All right, so first thing, put everything on a table. I did that. Step 2, go ahead and find what it's changing by and find the 0 step. The next thing we're going to do is we're actually going to find a rule for this. So the method that we use actually looks like this. And this works for linears. And if you're watching this video, you are in either 8th grade or you are in algebra. And there are a lot of linear functions in both of those classes. Alright, so what I'm going to do, whoops, this should actually be an N. Alright, so this is how it's structured, you see. This over here is what's called the input. This over here is what's called the output. Okay? The step number is, in these types of problems, that's always the input. So a lot of times students will ask me, how do I know what's the input, what's the output? Well, it's very easy. If it's a step problem like this, if it has to do with progression, if it has to do with time, the minutes, the hours, the steps, that's always here. The output is always the total number of things. So that's how you kind of know what goes where. But I colored this so you could see that this is the output, this is what the change is, this is the input, and then this is the 0 step. So for this particular thing, the formula for this would be that the toothpicks is equal to 4, because it's going up by 4 every time, times the step number plus the 0 step, which is 1. So now we have a rule. Now you might be saying to yourself, what are you even doing? You're not even addressing the questions. Well, actually, now that I have this, I can actually do any question I could ever be asked. So A says, describe the growth pattern shown above. Well, that's easy. It increases by 4 every step. Instead of it, I should say the toothpicks. There we go. So the toothpicks increase by 4 every step. That's what's going on. B, what is the relationship between the step number n and the number of toothpicks? There it is. We already did that. So that's what I said. If you start with a table and you go from the table to the rule, you can really answer anything that it asks you. So I would say the relationship between n, the number of, or the step number, and t, the number of toothpicks, is t is equal to 4n plus 1. Now a lot of times, this is something to be very careful of. On tests, when I ask a question like that, a lot of times students will just write this down, and that's it. But if you don't tell me what t is and you don't tell me what n is, you basically wrote half the answer. So keep that in mind. You need to write a sentence structured like that. And then finally, C says, how many toothpicks could be needed for the 40th step? Now this might seem silly, but I've seen this done. A lot of times kids will take this table and they'll actually take it all the way up to the 40th step. So they'll just keep adding 4. Well, I would not suggest that, because there's a very good chance that somewhere along the way you're going to misadd, and you're going to be off by 1 or off by 2, and you're going to get the answer wrong. So all you have to do is the 40th step would be here. So you just simply figure out the number of toothpicks. We know it's 4. It's the 40th step number, which is n. So you put 40 right here, and then we just add 1. So by evaluating this equation right here, we can just figure out how many toothpicks there'd be. So 4 times 40 is 160, and 160 plus 1 is 161. So again, start with a table, go to the rule, and once you have the rule, then start looking at the questions, and then you'll find it's very easy.